the movement was solidity is smaller than main machine and the consumed power is very small. This is the main difference of the main machine and the feed machine is the movement velocity. Okay. According to the movement velocity, we can and distinguish the main machine and the feed machine of different cutting processes, like the turning processes. The main machine is the workpiece. Due to the workpiece have the faster experience speed or and the feed machine have a low speed or velocity, and this is grinding. The main machine and the feed machine is different from the curling processors. The main machine is a tool, and the feed machine is a workpiece. Uh, I think all of you must know the difference of the main machine and the feed machine of different process. Okay, this is the first one important knowledge you must know, and then the important knowledge is cutting variables. Cutting variables consist of cutting speed, feed rate, and the depth of cut. I, this is an example of the turning processes. The cutting speed is rare is the workpiece of this is workpiece and the feed rate f is this is the movement of the tools, and the days of cut is this surface to this surface is the depth of cut. Uh, this is a very three important cutting variables during the mental cutting processes. This is the two knowledge you must know. And then is the structural elements of the tools. This is also very important. There are three important face and two important edge and one point. Uh, this is a rig face. This is a rig face. As this picture is this face. This face is through which the cutting chips flow out, and a leading frank. Leading leading frank is this frank. Leading frank. This frank is opposite the transition surface on the workpiece. In this picture, you can see maybe transition surface on the workpiece. This surface, okay, is the leading flag. And then is the trailing flag. Trailing flag. Trailing flag. The surface opposite to the machined surface on the workpiece is this flag is a trailing flag. Trailing flag. And one is the leading cutting edge. This edge is the intersection of the rib face and the leading flank. This is leading cutting edge, and then is trailing cutting edge. Trailing cutting edge is this edge. This edge is the intersection of the red face and the trailing flank. And one important noise is the pure noise in this noise, this point, in this point. This point is the connection part of the leading a cutting edge and the trailing cutting edge. Uh, all of you must know this important this structural elements of the tools. They are including three three flank or surface and two cutting edge, including the leading cutting edge and the trailing cutting edge, and one important noise, tool noise. Okay, you can you can combine this picture. You can combine this picture to understand the, the structural element of the tools. Okay. And then is some important orthogonal or plane reference systems. They are including some um, important plane, including the reference plane, PR. In this picture is this. In this picture is this plane. Is reference plane. Reference plane is a plane which passes through a designated point, point on the cutting edge and is perpendicular the direction of the main machine. In this turning processes, the main machine and direction is this. Is it in sorry? In this direction is a main machine of the main machine, and the reference plane is perpendicular to the main machine. Though this plane is main machine. Sorry, is a reference plane. This is the reference plane, and the cutting edge plane is a plane which passes through a designated point on cutting edge and is tangential to the cutting surface. Uh, this is a cutting surface. Cutting surface is this and perpendicular to the reference plane. So the plane is this plane this green plane is a cutting edge plane. This is a tan tangential to the cutting surface and the perpendicular to the reference plane. And another uh, important plane is orthogonal plane. Orthogonal plane in this surface is this. This surface is perpendicular to the PR and the cutting edge plane. PA is stimulationless. Display is display is perpendicular with the PR and the PS stimulationless. Okay, this three play is very important to understand the angle of the tools. So, you must learn this plane as first. Okay, and then is uh, reference system with the normal plane. There are two same plane with the orthogonal plane, the reference plane, and the cutting edge plane PS is the same with with the previous orthogonal reference, and the difference plane is normal plane. PN, this is a difference. It's a difference. Uh, and then is the reference and the reference systems with the longitudinal and transverse sections. They are transverse section. This is PP is transverse. Sorry. Uh, this plane is transverse section PF. This is longitudinal section of PP. And this two plane is perpendicularly and also perpendicularly with the reference plane PR. This is longitudinal and transverse sec, transverse systems. And another important knowledge is two angles. Two angles uh, in different reference systems. They are including uh, seven important angles we must know in these pictures. And the first three angles, important three angles is the two angles designed measured in the orthogonal plane. This is in this plane. They are Rick angle. Rick angle is between the Rick base and the reference plane. In this angle is a Rick angle. Clearance angle is between the flank and the cutting edge plane. This is clearance angles, and another is the wedge angle. This angle is in between the flank and the rig base. This angle is a wedge angle. Okay, and 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 then is the cutting edge inclination angle or back rake angle. This angle is measured in the cutting edge plane. PS. This angle is measured in this cutting edge plane PS. In this picture is this angle. This angle is measured between uh, the cutting edge and the reference plane. In this picture is this. This is cutting edge. The cutting edge. This this is the cutting edge, and this is a reference plane. So the cutting edge inclination angle is this angle, and another three important angle is major cutting edge angle. This angle is measured in the cutting edge on the reference plane and the uh, fading direction. In this picture, we can see that uh, this is this is a major cutting edge angle, and this is a minor cutting edge angle. This angle is included the angle between the projection of trailing cutting edge on the reference plane and the fading direction. And the last important angle is the north angle. North angle in this picture is this. This angle is included the angle between the projections of leading and trailing cutting edges on the reference plane. And then we studied the undefined chip dimensions. Uh, the undefined chips is a layer of workpiece materials removed from the cutting edge in a single cutting section. In this picture, is this section is undefined chip directions. We should we should uh, we should master how to calculate the undefined chip directions from these these shapes. This this is fade rate, and this is depth of the cutting. And so these two parameter we should learn how to calculate the undefined chip directions. Okay, and then we studied some important properties of the pure materials. The first is it should have the high hardness, and then it should have high wear resistance, and then the pure materials should have good thermal conductivity and the processing and properties. And then the two materials should have sufficient strength and the toughness. And then it should have a high heat resistance. And then we studied some important cutting tool materials. The first is high speed steel. It includes the plain high speed steels and the high speed steels with high performance. And another important cutting tool materials is cemented carbides. And cemented carbides is a section of metallical campus um, and powder in metallical parting materials, followed by liquid phase citrins. The allowable allowable cutting speed is 4 to 10 times than that of the high-speed stealth. So the simulated carbides have more excellent properties than the high speed steel. And other uh, tool materials include the ceramics, diamonds, and cubic bore on nitride. This is some properties of these three tool materials. Okay, and then we study the and and then we studied the basic theory of mental cutting processes. Mental cutting processes is a processes in in which the cutting tool is made to remove the excess metal in the form of chips from a roughness blank so as to generate a finished surface. In the metal cutting processes, a serious physical phenomena such as build-up edge, cutting force, cutting heat, and temperature, surface and hardening, and the tool will happen. In the last lesson, we studied the build-up edge, cutting force, and the cutting heat. In this class, we will still study im- some important physical phenomena. Uh, what is default in the metal cutting processes? Metal cutting is a process process during which the workpiece cutting layer and the execution of the tool produce plastic deformation and chips. It's in the metal cutting processes include the precise sliding, correct, and excision. And for these four steps, they for these three four steps. Okay, this picture is a sharing slide in the default the photo uh reaching for the deformation. It include some important steps from position one and two, three, four. Uh, the whole process of chip formation goes through four steps. That's extrusions, slathering, crackling, and segregating. Of you should understand the deformation processes and three important deformation rule. It include the first is the rule one in this in this in this rule. This rule is also this rule uh, is also knows the the first deformation rule, showing that the mental well showing the plastic or deformation, and then is red rule. This rule is default methods follows over the pure surface, and this rule is known as the secondary deformation rule. And then is this rule is called the third deformation rule. Is called extrusion and friction rule on the finished surface. This rule is on the finished surface, and the cutting edge a cutting edge has removed the materials of the workpiece. And then we studied the chip types of during the metal cutting processes. The chip types mainly include four types. The first is a ribbon chip. The ribbon chip I show in this picture uh, is this. This is a, a ribbon. This is like a ribbon. In this picture, we can see that this is a ribbon. Uh, it looks like very small and continuous. And then is a rock chip, a correct chip like this. This is correct. The correct chip has a clear defined style-like slides and smooth and surface. Like in this picture is like this. Uh, and this and the third type is a unit chip. Unit chip. Uh, in this picture is like this. And the unit chip is as the shear stress in the shear plane is more than the uh, ultimate strength of the materials to be cut. The chips are generated in the form of single segments, and the four is splittering chip. Splittering chip uh, is often happened in the hard and brittle materials to be cut. The larger the undeformed chip thickness, the easily the splinting chip is produced. And then we studied the build build up edge. The build up edge in this picture is this area, or in this picture is this area. This is when the metals are cutting at a middle cutting speed. It usually brings out about a phenomenon that a piece of metal adheres formally to the tool surface face and can cut the workpiece instead of the cutting edge. So the built-up edge is often adhere formally to the tool face. How to uh, decrease the uh, build-up edge? There are some methods. Uh, the first is to avoid using a speed at which build-up edge is easily found. In this speed area, if we should avoid using the speed, and then is to reduce the plasticity of the material to be cut, and third is to select the proper cutting fluent. Uh, the cutting the cutting fluent we will study in this class. And the fourth is to increase the increase the rake angle of the cutting tools, and to improve the sharpening quality of the cutting. This is very important to restrain the formation of build the up edge. And then we studied the cutting force and the cutting heat. The cutting force mainly includes uh, this is elastic and plastic deform force, and the other is tran uh, tran tractional resistance. In this picture, they are including uh, the this box. This is a picture. Uh, we can know the primary cutting force. Primary cutting force FC. This force is along the direction of the cutting speed. We see, and this is the cutting speed. This is the cutting speed. So the FC is parallel the cutting speed direction. And then is the back force, FP, is this. This force is perpendicular to the feed direction. FP is perpendicular to the feed direction in the tool reference plane. Uh, this is also called the rotational cutting force, and then is feed force FF. The feed force in this picture is here, and here. This force is uh, parallel to the feed direction in the tool reference plane. This is the feed direction. So this force is not is called the feed force. And the cutting power cutting power is the sum of the components of the resultant force power. Therefore, all the cutting power can be calculated by this formula, which is related with the main cutting force and the cutting speed. This is the cutting power. The cutting power is related to the main cutting force and the cutting speed. And then is uh, then is a specific cutting force. Uh, uh, the specific cutting force can be calculated as the following formula. By this, this is related with the AD, and and uh, and so the main cutting force Fc can be calculated by this equation. Fc is equal to the specific cutting force H and uh, they and the nominal cross-sectional area of cutting layers. This we have learned master class, and then we we studied uh, the effect of the cutting force. There are some factors where influencing the cutting force. There are many include the workpiece materials. The workpiece materials will have important influence for the cutting force, and and then is uh, the cutting force will affect by the cutting variables. It mainly include the feed and the depth of cut and the cutting speed will influence the cutting force, and then it is affected by ge geometric parameters of cutting tools on cutting force. It mainly includes the rake angle. The rake angle has the largest influence on FF and the smallest influence on FC. And then and then um, we will study the generation and the transmission of cutting heat. In this class, we will continue study this knowledge. Okay, uh, the cutting heat comes from the elastical deformation and the plastical deformation resulting from the metal cutting nails. The ways to conduct the cutting heat are cheap workpiece, cutting tool, and the uh, um, ambitious mediums such as air, cutting fluid, and so on. The main facts influencing the heating conducting are the thermal coefficients of workpiece, cutting tools, as well as ambitious mediums. So the main factor influencing the heat conduction are the coefficients, thermal coefficients of the workpiece, cutting tools, and ambulance mediums. Or the cutting heat generated in unit time can be calculated as this equation Q is equal to the primary cutting force um, multiply the cutting speed. Sun the Then we will study the cutting temperature and its influencing factors. The average temperature in the contact region between the chips and the rick face is called the cutting temperature. Cutting temperature depends mainly on the relationship between heat generation and heat dissipation in unit time. And then we will study the main influence factors on the cutting temperature. These are as follows. Uh, the first is the workpiece materials. Workpiece materials with the increase of the hardness and the strength of workpiece materials with increase of the hardness and the strength of the workpiece materials. Uh, as we can know, uh, it will include the power is the power consumed and the heat is generated will also all increase, and then it will include sorry the cut temperature will increase. So the cut temperature will increase. So the plasticity of workpiece materials, the plasticity of the materials will increase, and then the cutting temperature uh, will increase. So uh, the workpiece materials will increase, and then the cutting temperature will affect by the cutting variables. It will the FC is the speed of the cutting, and the F is the feed rate, and AP is depth of the cutting. This will uh, have different effect degree on cutting temperature. In these three parameters, in these three parameters, the cutting speed will have the largest effect on the cutting temperature, and the next is the feed rate, and the last is the depth of cut. Cutting temperature has, has direct effect on the tool wheels and tool knife. According to the above uh, above zero, the use of larger AP and F is more favorably than that use higher cutting speed in order to improve the tool knife and control the cutting temperature in a suitable range. And the third uh, is geometrical parameters of cutting. Uh, the, the first is the influence of rig angle on cutting temperature. The unit this is influenced by the rig angle. The unit cutting force could decrease, cause the reduction of cutting heat generated. Therefore, the cutting, therefore the cutting temperature drops, and then uh, and then the cutting temperature will affected by the cutting edge angle or the cutting edge angle on cutting temperature. With the decrease of the cutting edge angle could lead to increase the cutting width and the tool nose angle. This should this situation can improve the heat dissipation condition of cutting tools and reduce and it will improve the heat dissipation direction and reduce the reduce the cutting temperature. Okay, maybe it's time for break. Let's have a break now. Thank you. Have a break.
Okay, Lausi. All right.
Hello everyone. It's time for
Yes, Lao.
class.
Hello, 老师。
Hello, it's time for class. Okay.
OK，老师。
老师
Okay. Last class we have studied the generation and the transmission of the cutting heat, and we know all the generation and the transmission of the uh, cutting cutting heat and the cutting temperature and its influencing factors. Okay, there are many include the workpiece materials. There are many include the workpiece materials and the cutting variables and the uh, geometric parameters of cutting tools. And this class we will study the tool wheel and the uh tool knife. When the cutting tool is used to cut the metal in processing processes, it will gradually. When the cutting tool wears to a certain degree, it will become failure. Abnormal abnormal tool wear will increase the tool consumption and decrease the productivity. Therefore, the analysis of tool wear mechanism has an important significance for selection cutting conditions reasonably. Using the cutting tool correctly and uh, determining the tool knife. Okay, and the first is the tool wear force. The tool wear force can be divided into normal wear and abnormal wear. Uh, the normal wear is the reference to the phenomena that the cut materials particles are um, on the on the connected surface between the card and the workpiece or chips are taken away by chips and the workpiece. And the normal uh, um, abnormal wear is also called the breakage, refers to the tool tipping cutting edge turning, cracking, flanking caused by impact or vibration or similar effect. And the tool wear forms, the normal wear includes the following forms. I show in these pictures. This is a, a rake face wear. The creator wheel is uh, dom, uh, the uh, by this KT. This is a creator wheel, and the second normal wheel is flank wheel. Flank wheel is denoted by VN. This is VN in the middle part of the cutting edge. This is the middle part of the cutting edge, and the wheel is homogeneous, and the average value is noted by the VB. This is parameter, and then is the wheel on both brake face and brake. This is where Rick face. This is real Rick face and the break. By this the two where are both Rick face and break occurs stimulations stimulationally. It usually happens when the plastic metal is machined and the thickness of the undeformed chips is more moderate. The HD, the HD is about 0.1 to 0.5 millimeters. And the cost of the 12 well. The 12 well is caused by mechanical and chemistry effects and the conditions of the high temperature and the high pressure. It mainly includes follow wells. The first is uh, the first is abrasive well. Abrasive well occurs in metal cutting when some small hard particles on the friction surface on the chips or workpiece slide over the surface of the tool to lead to grooves. Actually, abrasive wear is the main cause of the tool wear on the low cutting speed. On the low cutting speed, uh, aber- abrasive wear is occurs. This is with some small hard particles. This is the main characters of the abrasive wear. And then is adhesive wear. Adhesive wear is a phenomenon of the cold welding caused by absorption of finite between molecules on the new surface of a friction where between the tool and the workpiece. If the two surfaces undergo relative slightly emulsion, the welded points at the interface will be broken and the adhesive weld is produced. Adhesive weld depends on the temperature and the chemical component of the workpiece and the tool materials. When cutting at low and middle cutting speed, adhesive weld is the main cause of the tool wear. The adhesive wear will happen when the cutting speed is slow and the middle cutting speed is where the adhesive wear is many cause of the tool wear. Another is a defying wear. This phenomenon will happen that the chemical composition of tool materials and the workpiece materials occurs occurs uh, mu- mutual de diffusion at a high temperature is called the diffusion temperature. Diffusion where mainly on the temperature in tool works interface. The diffusion where depends on the temperature tool work interface. Okay. Uh, the fourth is oxidation oxidation wear. When the cutting temperature reaches to 700 degree to 800 degree, the cobalt, tungsten, and titanium combat of the combat alloy uh, organized in the air, generating the organizing fields, such as this force with low hardness and strength. These oxides are these oxides are loosely joined with the tool materials and are easily rubbed away, away by chip or workpiece, causes the oxidation wear to the tool. Or to sum up, tool wear is determined by the cutting temperature. The wear is determined by the cutting temperature. Diffusion wear, and the organization wear are mainly the main causes of the tool wear at a high temperature. Within low middle cutting temperature, origination adhesive wear is sometimes the major causes, but the rough and Russell wear existence in all kinds of cutting temperatures. Presentation that the diffusion wear and the organization wear are many caused in the high temperature and with low and the temperature and the low middle cutting temperature region adhesive wear is sometimes and the wear and the abrasive wear existence all the cutting temperatures. Then we will study the tool wear processes and the wear criteria. When the tool wear is up to a certain volume, uh, wear criteria, the tool should be replaced and the resharpened. As first, we will study the tool wear processes. as shown in this picture, the 12-well processors will include three steps. The first is initial well process stage, and B to C is normal well stage, and after C is series well stage. The 12-well processes, the changing process of Frank will be with time called the 12-well processes. It is divided into three stages. This three stage is called the 12-well of processors. The first is initial well stage. Initial well stage. After sharpening, as shown in this picture, we can see that at the trial surface, at the trial surface, roughness is quite large. The surface is easy to wear. In this stage, the trial surface roughness is quite large. So the surface is easy to wear. So the wear line is formed quickly in this stage. In this stage, the wear line is formed quickly. The degree of the initial wear depends on the trial sharpening quantity. The degree of the initial wear depends on the trial sharpening equality. And then is normal wear stage. Normal wear stage. In this stage, due to the rugged parts to the trial surface have been ground. So the amount of trial wear steadily increases as time goes by. In the normal wear stage, the wear curve is we can see that the wear curve is basically a straightly line inclined upwards, and its slope denotes the intensity of pure wear. Wear intensity is one of the important indexes in evaluating the pure cutting performance. Normal wear stage is the effective work stage of the tool. Normal wear stage is the effective work stage of the tool. And this is a series wear stage. A series stage, when the tool will be developed to a certain degree, the tool is aggravated with the cutting force and the cutting temperature increasing respectively. In order to guarantee the machining quantity and reduce the tool consumption, the cutting tool should be reshaped or replaced before this wear stage. Before this wear stage. We can, in order to guarantee the machine quality and reduce the tool reshuffling. After this, after this stage, we should reshaft and replace the tools before this will stage. The tool will correctly uh, it means that the wheel limit the determines the cutting tool should be resharpened is called the wheel correction. This is the definition of the wheel corrections. On the ISO standards, wheel correction means that the uh, allowable maximum value this is allowable maximal value of the average wheel in the middle part of the wheel rule and is denoted by VB. The tool wheel correction depends on the materials, workpiece materials, and the cutting temperature. Uh, this, uh, this effect we have studied by the last lesson. It's mainly depends on the tool materials, workpiece materials, and the cutting conductions. And then we will study the tool knife um, empirical formula. What is the tool surface knife or the tool knife? In practice, in order to judge the tool wheel situation easily, quickly, and accurately, tool knife is usually used to reflect the wheel correcting in indicatively. Tool knife is a tool knife is a time. Tool knife is a time in which a new or sharpened cutting tool is used actually for cutting from the start of the cut to the wheel limits, denoted by T. Its unit is second or minute. The tool surface knife we can know is the time which is the new sharpened cutting tools. Okay, and then is the relationship between the cutting variables and the tool knife. The first is uh, the first is VB and the T relationship. The relationship can be calculated by this equalization. Um, the speed, this is temperature, and A is the coefficient related to the experiment condition. The M is the exponent depending on the characteristics of the workpiece and the tool material. Its magnitude reflects the influence degree degree of the speed we see, and the temperature. The large of the value of m. From this equation, we can see that the large the larger the value of m, the low effect of the Vc on temperature on T. The large of m, the the low effect of Vc. We can see from this equation. And then is the relationship of F and T and AP to the T. It can be a calculator in the same way the relationship between the F and the T and the AP and the T can be calculated uh, by this equation. Taster shows that the larger the feed and the depth of the cut the low and the trail nap will be low. But the effect of feed on the T is large. The feed on the T has a large effect of depth. Have this F have a large effect on the T. Okay, and then is the equation of the trail knife. Equation of the trail knife. When using the cutting tool in production, a rational tool knife should be determined firstly based on the pre predetermined t. The cutting speed we see is called or selected, and then the cutting efficiency and the cost are calculated. At present, uh, there are two methods to dimension the tool knife. The first is this uh, by this T and VC, where the CT or CV represents the coefficients related uh, to the workpiece materials. This is related to workpiece materials, tool materials, and other cutting directions. And XV and VV represent the index. Next page. And other facts affect the tool knife. All the facts are affect the cutting temperature. Could could affect the cutting temperature. Could have affect the tool knife in the same way. And the performance of the cutter material has very large effect on tool knife. And the low and the higher the hardness of the tool materials is, the high the hot hardness of the tool materials is, the better the wear resistance of it. So, the longer of the tool or knife, If the materials have the higher the hardness, the better of the wear resistance, and the tool knife will be longer. And then impact cutting or even cutting conditions, or when cutting the hard to machine materials. The main factors of influencing on tool knife are strengths, are the strengths and impact toughness of tool material, and the how the strength and toughness of tool materials are, the longer the tool knife. The longer the tool knife, if the materials have a high strength and toughness, the tool knife, will be longer. Okay, this is the effect of the tool knife. And the next we will study the the 1.4 applications of the basic theorem of cutting processes. In this part, we will study the application of the basic theorem in the cutting process. In the application of the basic laws in the mental cutting will be introduced in this section. Many issues include how to control the chip, how to improve the motionability of the work materials, how to select the cutting fluid, how to determine the 12 geometrical parameters, how to select the machining variables, and so on. At first, we will study how to control the chips. The first is the control of the chips. In high speed turning, the control and the disposal of chips are important to the operator and cutting tools. As shown in this picture, indicates the fractal situation when the chip collides with workpiece or tool break. As shown, we can know that the larger and brittleness of materials, the large the chip thickness, and the smaller the chip kernel radius, and the easy to chip breaks off. First, we will study some parameters. The first is chip break. Chip break. The chip break means that the glue stay machined and all block clamped on the brick face, as shown in this picture. Uh, as shown in this picture, it is provided to control the ribbon-like chip that are formed at a high cutting temperature. The chip breaks, cools, and highly stresses the chips and causes it to break into small pieces so that they are easily removed from the machine. And the first is a chip break. The second type can break chip in the chip from C or 6 in the wide cutting variables range. It has the uh, broad, broad, broadest chip break range. The next is the parallel type. Parallel type. Uh, the third type often this is third type. It often breaks chip in the form of long and tight spiral roll and has narrow chip breaking range, which is suitable which is suitable which is suitable for semi-finishing and finishing with small depths of cut. And two is proper selection of tool angle. The cutting edge angle is the main factor influence the chip break. Uh, the increase of cutting edge angle can make the cutting thickness increase. It will increase the cutting thickness, which makes for breaking chip. The lace cutters with good chip breaking effects in practice often have large the cutting edge angle. The angle within the 60° to 90°. To decrease the rake angle can enhance chip deformation and makes it easy to break chip. To change the inclination angle can control the direction of the cut chips. The three is change the cutting variables. Of the three cutting variables, a feed, the feed has the largest influence on the chip breaking. The next is the depth of the cut AP. The smallest one is the cutting speed. The last one is the cutting speed. The influence of the uh, feed can be increased chip thickness and is favorable to chip breaking. But it could increase the surface roughness. But it could increase the surface roughness. The decrease of VC can increase cutting deformation and is called favorable to chip breaking. But it could decrease the material removal efficiency. Therefore, the cutting variables should select properly according to the practical conditions. Uh, we can see that the feed has the largest influence on chip breaking, and the next is the depth of the cut AP, and the smallest one is the cutting speed. This will have changed to the cutting variables of the chips. And uh, next part is motionability. Motionability. Ch chips may be cut from some materials with relative case and from others with greater difficulty. This difference may be attributed to the motionability of the respective materials. Motionability is defined as the degree of difficulty with, with which the materials is cut satisfactorily for the purpose intended. In generally, good motionability is associated with removal the materials with uh, moderate cutting 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 force. The formation of rougher small chips, longer tool knife, and good finishing. It is commonly It is commonly observed that the materials with a high hardness have a poor motionability because of the high temperature, large pure large power consumption, and rapid tool wear. However, the hardness alone could not able to uh, specify the motionability, since it also depends on the other facts such as the mechanical composition of materials, microstructure of material, and the physical properties such as the tensile strength, ductility, and hardness of the workpiece materials, and the rigidity of tool and work holding degree device and the cutting variables. And then we will study the motionability uh, of the tool. One is a primary index for assessing materials motionability. The tool knife or cutting speed permitted and a certain tool knife and the relative motion ability by this equalization, where the Kr is the relative motionability index and the Vi is the cutting speed of and the Vi is the cutting speed of the material to be investigated when tool knife is T, and VS is the cutting speed of material standard steel for 60 minutes or plain metallic materials tool knife or 20 minutes is for hard to machine materials tool knife. If the KR is more than the one, it means that the work material means that the work materials investigated is easily to be cut than the steel 45. If the KR is lower than the 1, it means that the work materials investigated is more difficult uh, to cut than steel 45. From this uh, equation, we can see that if the work material if the Kr is more than the 1, it means that the work means that the uh, work materials invested is easy cutting than the steel 45. Uh, this number is compared with the steel of 45 steel. Uh, and the primary index used for assessing materials variables. The second is the surface roughness. The surface roughness and the same machining conditions. The grades of the surface break roughness can be compared. The the smaller the surface roughness, the better the smaller of the surface roughness, the better the machinability of the work materials. It means that if the work the surface roughness is smaller, the work materials will have a better machinability, and then is the cutting force, and the cutting force. If the cutting force the cutting force generated in the cutting processes, the more the power consumption. It means it should more power, and the worth of the machinability of the work materials, and then is easy to the chip control. The easier to control the chip flow direction and the brake chip, the better the machinability of the work material. If the materials have easy to control the chips flow direction and the brake brake chip, the better the machinability uh, ability of the worker piece. How to improve the machinability of the work materials? There are some ways to improve the machinability of the work materials. One is to one is to regulate the chemical composition of materials. The machinability of the plain carbon steel for steadily as its carbon content increases. And the second is a proper heat treatment to transfer the microstructure of the metallic materials by means of heat treatment is the primary method to improve the motionability. For example, the motionability of the low carbon steel can be improved by a normalization, whereas the motionability of a high carbon steel can be improved by a spiralization. And then to select the structure of the uh, state of state of materials. The motionability of low carbon steel in the cold drawing state is better than that of the natural state. The motionability of hot cost blocks is better than the forged forged bricks. Okay, this is some um, knowledge in this class. Uh, it's a break time. Have a break now. Have a break. Thank you.
OK，老师。
Hello, hello, everyone.
Hello，老师。
Hello. Let's
Hello, hello,
continue
hello.
study. Okay.
Yes, please.
Okay. Next lesson we study the measure to improve the emotional ability of the work materials. It can be improve the materials by the selector regulate the mechanical composition of the materials and then uns- un- choose the proper heat treatment and then to select the structure of the state of materials. In this class, we will study the uh, some other knowledge. At first is the cutting influence. In the first is the introduction of the cutting influence and the function and the function. The middle in which of the cutting process take place is called the cutting influence. This is the definition of the cutting influence. Uh, is in the medium in which cutting processes take place. Okay, and a cutting fluence may be defined as any liquid, solid, or gas which is applied to the workpiece material or to the cutting tool to assist in the cutting operation and which um, facilitates easily motioning. When the cutting influence was first introduced, it, it was it was to assist in preventing the plain carbon steel tools from overheating, which causes by cutting edge to softer and wear quickly. Keeping the temperature of the tool low resulted in a much longer tool life. And the second part is fraction. The second part is the fractions of the cutting influence. The cutting influence have to perform the variety of tasks in several different ways. The duties may be divided the duties or the function or the duties uh, may be divided four areas uh, dealing with the cooling and fabrication and washing and surface finishing. Uh, at first is cooling. The cooling, the overheat of the cutting area may produce the following difficulties: uh, expansion of the workpiece, leading to main difficulties and possible errors in size of the workpiece. warping caused if the heating is one place along the work. Productionally, local dis distortions welding between the work and the center of the lathe or grinding machine. As the job expands and the fractional weld occurs, reduction of tool knife. The cooling fraction of the cutting fluid exists in abstractly the heat generated during the hard process. As we know, the cooling properties of the cutting fluid depends on a large extent on the cooling methods. The cooling efficiency increases with heat conductivity and specific heat of the cutting fluid. Cooling effect increases too with the flow rate of the fluid, the area of the application, and with the decreasing temperature of the cutting fluid. And the second is lubrication. As the tool is forced through the workpiece, they are areas of high friction between the swap and the tool face. Lubrication helps to reduce this friction and has the following advantages. It can reduce the fractional heating effect and lowering the chip's resistance to sliding, which means less force on the tool and lessening the power used in cutting and reducing the tool wear as metal-to-metal contact is avoided. And three is washing. And cutting fluids help to wash away swab from the cutting area, which has the following advantages. It is easy to observe the cutting action so that incorrect cutting can be easily noted. And two, it is safer since there is less chance of tooling breakage caused by the swarf clogging during drilling, milling, swallowing, and grinding. And four is surface finishing. Because of the lubrication action, there is smoother cutting action and resulting a better surface finish on the work. Since there is less chance of turning occurring, less chance of the forming of BOE, less chance of the following of BOE, which may lead to eventually tool failure. And three is more accurate workpiece, especially when cutting centered as the surface are more much smoother. This is a fraction of the cutting fluent. There are many including the cooling, fabrication, washing, and surface finishing. This is the main function of the cutting fluent. And and the three is and the three is a type of the cutting fluent. The first is the there are three type there are three types of the cutting fluents. They are water-based illusions and straight mirror oils and uh, mirror oils with uh, uh, details like net oil. We will study this knowledge. The first is water-based emulsions. Poor waters is by far the best cutting fluent variable because of its highest heat calorie, uh, including high specific heat composite. Besides it is cheap and easily available. The water is very cheap and is easily available. Its low solidity makes it can flow at a high speed through the cutting fluid system and also the penetrates the cutting room. However, the water coincide are the work materials very quickly, and particularly at a high temperature prevent in the cutting room. The machine tools, parts on which water splotches could be corroded. Therefore, other materials should be added to water to improve its wetting characteristics. And the second cutting fluent is straight uh, mirrors oils. The term straight when applied to lubricants and coolants means means and uh, means undiluted. This they are pure mirrors oils with any details. Their main functions is lubrication and rust and the rust prevention. They are chemically stable and low in cost. However, the effectiveness as a cutting influence is limited, and therefore they are normally used for high machinery operating, such as uh, lane, the lasers and single splitting automations where free cutting braces and steel are being machined. And the third type cutting fluent is mineral oil with additives. This is by far the largest variety of cutting fluent variables. A number of additives have been developed which, when uh, added to the minerals oil, could produce the desirable characteristics for different machining situations. Many difficult to machine situations could be easy to using these cutting fluids. They are generally named as net oils. The details generally improve the loading capacity as well as the uh, chemical activity. The explained oil are mixtures of mineral and fatty oils. They are suitable for heavily duty operations such as threading, extreme prayer, cutting oil are minerals oils containing extreme prayer additives like the samples with in branch operation, also called oils, are quite commonly used. And four is how to selection the cutting, how to selection the cutting fluent. The cutting fluent should be carefully selected. It is observed that each mental brain machine and even each type of machining has its optimal cutting fluent. The selection of a specific cutting fluent depends on the following factors. The first is cutting variables. The cutting variables is very have is must be considered when choosing the cutting fluent. And the two is workpiece materials. Different workpiece materials should select different cutting fluents. And three is tool materials. Uh, Tool materials like the HSS tools generally have better hot hardness. For general machining, water-based cutting fluids can be used, but for every cutting EP net oils are preferable. And four is expanded tool knife. Uh, if we want the expanded tool knife more longer, we should choose the uh, proper cutting fluents. And five is the cost of the cutting fluents. When we choose the cutting fluent, the especially in the factory, the cost of the cutting fluent is must should be a considerable. and 1.4.4 is the proper choice of the two ge- mm, geometrical properties. Two geometrical properties include the two angle, shape of cutting edge, type of rake face, and the freak, and so on. Um, whether the choice of the two uh, geometric parameters is rational has an important influence on the tool service life, machining quality, and the productivity and the machining cost. As first, the is the choice of rake angle and the type of the rake face. The first is choose the rake angle. To increase the rake angle, can decrease cutting deformation, thus decrease cutting force, cutting heat, and the cutting power, and improve the tool service life. It can also restrict the BUT and improve the service quality. Uh, the general perception in the selection of the rake angle is to choose the uh, large, larger rake angles as far as possible on condition that the tool knife can be insured. This factor should be considered as follows. The first is the workpiece materials. It is rational to choose uh, the first is the workpiece materials. It is rational. It is rational to choose a larger uh, gamma lane rig angle for uh, Datial metal and a smaller break angle for brittle metals. The higher the strength and hardness of work material, the low the angle, the better the plasticity of the work materials, the large the rig angles. And the second is a 2 point materials. It is rational to choose larger rig angle for HSAs and a smaller rig angle for combat and ceramics. And the second is machining equipment. It is rational to choose smaller rig angle. Choose a smaller rig angle for roughly and large rig angle for finishing. For the smaller rig angle for the forming tools have the advantage of reducing the fall error of the back cutting edge, thus improving the machining accuracy of the workpiece. And then is the types of the rake face and its choice. There are several types of rake face as shown in this picture. They well the big the B a beta uh, gamma one represents the land width, the first surface, and this is represents the Rig angle on the first phase land. The type showing in this picture is used for single point or multi point precision cutting tools, such as forming tool, milling cutter, a square cutting tool, and gear cutting tools. The figure B, the type is used for making carbide cutting tool to cutting the materials with higher strength and hardness. And figure 3, A, the type is suitable for the tools with the wheel racing on both brake face and flank stimulations. And the figure D, it shows is mainly for the roughening plastic, metal or bowling. And the figure E, it shows has a very narrow flat surface with this the strength of with the strength of the cutting edge gets increased because the uh, because this is because this is very small and the land has nearly no influence on the cutting fraction. And then is a choice of choice of the clearance angle and break. The clearance angle is also an important uh, geometrical parameters. To increase the clearance angle can decrease the friction between the frame and the machined surface, and improve the quality of the machined surface. But with the increase of the clearance angle, the wedge angle and the cutting edge strength decrease. At the same time, the volume of the dispelling heat becomes smaller and causes the cutting temperature rise and speed up the tool wear. For the same wavy, a for the same wavy value as shown in this picture, as the same wavy value in this picture, when the clearance angle increase from this to this, uh, from this picture can be seen the materials volume consumed by reshuffling tool increases. Besides, the ratio of wheel volume NB becomes larger. The ratio position of the tool points is changed clearly, thus affecting the machining accuracy. The principle in determining in the clearance angle is to choose the smaller clearance angle as far as possible, and the condition of not pro, production friction. The factor should be considerable as follows. The first, the first is machining accuracy. Because of the small cutting force in finishing, and the larger clearance angle can be a the large clearance angle can be selected to prevent friction. In roughness machining, smaller clearance angle should be selected to increase cutting tool strength. And two is workpiece materials. Workpiece to materials. The larger clearance angle should be selected uh, for the cutting ductile metal so as to reduce friction. The smaller the clearance angle should be selected for cutting brittle metals or cutting steels with high strength and high hardness so as to increase the tool point strength. And then is the type of frank and its choice. The first is double franks with two positive clearance angles, as show as show in these pictures. The advantages are the tool resharpening workload and decrease the tool wear amount. The two is land of the first frank, as shown in this picture. The fraction of the land of the first frank is to increase friction between the land and the cutting surface, forming damp effectiveness to enhance cutting stability and avoid vibration. Therefore, therefore, the land of the first flank is called dumpling land. Is called dumpling land. And the three is a choice of leading and mirror cutting edge angle. The first is choose the leading cutting edge angle. The specific principles in the selection of the leading cutting edge angle are as follows. The first is to choose the large leading cutting edge angle if the technically system rigidity is insufficient. Generally, the leading cutting edge angle equal equals 60 degree to 70 degree. And the two is to choose the smaller leading cutting edge angle, or to cut the metal materials with high strength and hardness. And the three is to choose the cutting tool with the selection of the leading cutting edge angle or equal the 90 degree to machine the shaft with shadow. The principle in selection of mirror cutting edge angle is to choose the smaller milling cutting edge angle, and the premise of not producing friction and and uh, and the variables. The value the value the value of the leading and the mirror cutting uh, the leading and the mirror cutting edge angle are shown in this table. We can see that different cutting materials and different materials should choose different leading and mirror cutting edge angles. Uh, we can choose the leading and the mirror cutting edge angle by our requirements. And four is the choice of the cutting edge, cutting edge inclination angle. Choose the cutting edge inclination angle. Uh, One is the fractions of cutting edge inclination angles. It is effect on the surface quality. To choose the cutting edge inclination angle, can choose the chip following in direction to prevent chip from scratching machine surface. The influence of the cutting edge inclination on chip following direction is uh, in I is shown in this picture. In different edge inclination angle, it can be seen that the chip follows chip follows to the machine surface when the cutting edge inclination angle are smaller than zero, and to the surface and the surface to the machine when the cutting edge inclination angle are more than zero. And two is the effect on the sharpness of cutting edge when the cutting edge inclination angle is smaller or equal the 45 angle degree. The work rake angle and the clearance angle will increase with the increase of the cutting edge inclination angle, thus uh, increasing the sharpness of the cutting edge. And the third is the effect of the tool bit strength and heat dissipation condition. This is to choose the cutting edge inclination and angle, can increase the tool bit volume and further increase tool strength and improve the heat dissipation condition. And four is effect on the magnitude and the direction of the cutting force. In general, the and the in general the the cutting force of the cutting tool with the cutting edge inclination angle lambda s is more than the zero, is smaller than that of the cutting tool with the cutting edge inclination angle smaller than zero, with the increase of this with the increase of the cutting edge inclination, the radial thrust force could increase significantly, thus leading to the deformation of the workpiece and the vibration of the technical system. And two is choice of the cutting edge inclination and angles. To sum up, the cutting edge inclination angle should be selected according to the tool of bear strength, chips, follow directions, and specific machining conditions. Take the cutting edge inclination angle or equal 0 degree to 5 degree for finishing, and cutting edge inclination equal 0 to mirror of 5 degree for rough cooling. For the situations such as discontinuous surface, ununiform surplus materials, and so on, the cutting tool with the cutting edge inclination angle should be selected. If the rigidity of technical system is insufficient, the cutting edge inclination angle should be avoided as far as possible. And 1.4.5, proper choice of cutting variables. The magnitude of the cutting variables has a critical influence on the machining quantity, productivity, and machining cost, especially for batch production and the processing on the automatical machines, transfer lines, and CNC machine tools. At present, cutting variables are mainly determined by means of cutting handbooks, practical experience, and technical taste in many factors. The principles and methods to select cutting variables rationally are mainly introduced in this section. The first is principles The first is a principle. Sorry. The first is a principle to select cutting processes. Uh, productivity means that the number of the quantified products produced in unit time. It is selected to the machining time and mental removal rate. The first is the machining time, and the machining time it is an index uh, to measure whether productivity is high or low take the cylindrical turning for example. The machining time can be calculated by this equation. Where the in this equation, the LW represents the length of the surface to be cut, and the L1 represents the cut in length, and L2 in this is represent the cut out length, and the H is total machine endurance. The suitable OVC can be calculated by this equation into the equal one to 68. Then the machining time can be calculated by this equation. And two is the mental removal rate. Uh, Q stand for the volume of the mental cut per minute. It is the other index to measure the cutting efficiency. Q can be calculated by this equation, where the Q represents the mental removal rate, and AP represents the depth of the cut. F represents the feed. VC represents the cutting speed. And then is machine tool, machine power. As for the influence of the feed rate and the depth of the cut uh, on the FC test has shown that the influence of the AP on FC is larger than the feed. So uh, we'd rather choose a large F than the large AP within the Lawrence machine knowable machine power. And three is a true knife. We should give a priority to choose the large AP is the depth of cut, and then the F. At last, we should determine the cutting speed according to the tool knife. And four is surface roughness. And four is surface roughness. It is well known that the BUT has a harmful effect on the surface roughness because the BUT is formed easily at the middle cut speed. It is easily it is easily found at the middle cutting speed. It is rational to choose either low cutting speed or high cutting speed in finishing to avoid forming the BUT so as to decrease the surface roughness. For the cutting materials with straight cutting edge, the North ratio is equal to 0, as shown in this picture. The surface roughness can be calculated, and for the cutting tools with noise 0, with radiation more than 0, as shown in this picture. Uh, the maximal surface roughness can be calculated by this equation when the when this noise radio more than the 0, it can be calculated by this equation. And as for AP, it is not clear affect the roughness, but also AP increase the chapter could appear in cutting processes. Therefore, the small AP should be selected in finishing in machining. As seen from above, the rulers of selection machine variables are to choose to choose the AP as as large as possible firstly, and then in a large feed. Lastly, a proper cutting speed should be determined according to the allowable tool knife, machining power, and other specific conditions. And the two is mission methods of selecting machining variables. The one is selection of depth of cut. The first is depth of cut AP is determined mainly according to the excess metal on workpiece surface. In general, the roughly annuance should be removed in one pass as far as possible. Whereas in finishing turning, the depth of the cut will depend on the types of workpiece and the surface finish required. Because the finishing announce is small in finishing, it is usual to remove all surplus materials. But when the machining allowance is larger, uh, it should be removed by 2 or more cuts. In any case, the depth of the cut uh, should not be selected. Uh, the the two is a selection of tool. They are there are some reference value of the feed on roughly combined combined with the combined and HSA's turning tools are listed in this table. And the carbide and the HS turning tools are listed in table. In finishing, In machines, F is usually determined according to the requirement for the surface roughness, and and three is selection of the cutting speed after the AP and the F are determined according to the stimulated tool knife. The allowable cutting speed can be calculated by meaning of the by this equation. The coincide and its opponent uh, equal can be obtained by looking up the machining processes handness. In practical production, the general principles of choosing the cutting speed are as follows. The first is the low cutting speed should be selected in rough machining, and high cutting speed can be used in finishing machining. And two, the lower cutting speed should be selected when cutting the materials with a high strength and hardness. The poorer the machine ability of material to be cut is, the low cutting speed is used. The better the cutting performance of the tool material is, the higher the cutting speed. 3. The intermittent cutting or when cutting, casting, or forging blank with a hard surface, the cutting speed should be reduced appropriately in order to decrease the impact and simmer stress. And four is the low cutting speed should be selected when cutting large workpieces, long chapter, and thin wall workpiece. If the process system has poor geological, the cutting speed, which could cause self-exciting vibration, should be avoided. Okay, this is all the knowledge in this chapter. Uh, Everyone, please pay attention to that. That in the next lesson, in February, uh, we will have a we will have an experiment lesson. I will inform you in channel, and I will inform you as a specific location in the WeChat group. Okay, next
Okay,
class.
Okay.
Losh.
Okay, next class is experiment lesson,
Actually,
and
your screen
I
is paused. We can see.
I will assignment a homework on the WeChat. I hope you
Okay, Losh.
can. I will assign a homework on the WeChat. I hope you can give back to me the homework last Friday. Okay, by I will assignment the homework on the WeChat group today. Okay.
Okay, Losh, but please send the PPT.
Okay. I will send my PPT into the WeChat
Okay, Losh.
WeChat after this class. Okay.
Okay,
Okay, Loshi.
It's all the class today. Thank you
Okay.
everyone.
Thank you, Lashi. Thank you.
You're
Bye-bye.
welcome, Loshi.
Bye-bye, Lashi.
Bye bye, Sally.
Lava, you just woke up. Yeah. Look how your voice is heavy.
You speak too much. Let Loshi speak every time. Okay.
Woke up.
Lava
Hey,
just
who's
woke up. I'm very sure Lava just woke up.
I'm the first student. You know me.
So wait, how many people are online now? Hey, guys, what's up? Wake up, wake up. We are here. We are done.
Sally, don't joke.
I'm not joking. I'm not joking. They are all awake. They are all awake.
I'm very
Guys.
tired to do this class for
Yo,
3
Charlie,
hours.
we need
Hey,
to
what's
write.
up?
We need to write our names in the chat.
I don't think so.
Teacher, you already finished.
I don't think so.
You are late.
We need to write the name in our
Guys,
chat.
guys. Good night. Good night. See you guys.
Yo, Sally,
Yo,
do we need to write our names in the chat? Is
you're
it a
asking
must?
me. I don't even have mine in the chat. Shall let me write it. Who knows?
Oh my God, before you leave, you're gonna write your
Yes. I'm gonna leave my legacy.
Sally fuma bruca fulgence.
So she's urgence.
spiritual symbol.
Zeljan.
Zeljem.
See you guys. Enjoy. Bye-bye.
Enjoy what?
Suedia.
Class at 2.
Water. Suedia.
So they are coming with the naming.
That's square.
The teachers, this nonsense you're doing, Bob. The teacher didn't ask for this. See your life. Shakanaenda kugurira kamera.
Nta bibazo ufite.
Nabi
Ndabyanze.
hariho aka recording hejuru ikiza kuri YouTube nuko
Yeah. Wisi wanjye Rushman.
niwe nyene.
Kanzibe ngende.